Real numbers have different properties which are helpful when you're solving and simplifying algebraic expressions. And when you're just working with numbers too. So first one, commutative property of addition. We use this all the time. So if I tell you, 2 plus 10, that's the same thing as 10 plus 2. You've used the commutative property. So when it's addition, because you're adding the 2. The associative property is changing the grouping symbols. So as long as you keep things in order, you can change the grouping with addition. So this would be like if you're trying to add 2 plus 99 plus 1. You can either group up 2 plus 99 and then add 1, or what I would do to add this, I would actually group up 99 plus 1, because that makes an easy 100, and then add 2. So the order is staying the same, but you're changing your grouping symbols. The identity property of addition is, identity means what are you going to do to the number to get itself? So the identity for addition is 0. So anytime you add 0 to a number, you're going to get the original number. So that's the identity property of addition. Inverse is, what do you do to get the identity? So this is A and negative A are called additive inverse because they add up to the identity for addition, which is 0. So another example would be negative 6 plus 6. These are additive inverses, and they're adding up to the identity. So the identity for addition is 0. And the identity for multiplication is 1. So just like you have commutative property of addition, you have multiplication, which means that it doesn't matter the order that you multiply something with, it's still going to be the same answer. As well as it doesn't matter how you group up the numbers. So if you do 3 times 10 first, it's also going to give the same answer if you do 2 times 3 first. So those can help you with shortcuts for multiplying numbers easier. And identity property of multiplication. So the identity for multiplication is 1. So anytime you multiply a number by 1, you're using the identity. Multiplicative inverses are what's called reciprocals. So 5/4, the reciprocal of 5/4 is 4/5. These are also called multiplicative inverses because when I multiply them, I get 1. You'll get 20 divided by 20, which is 1. And the symmetric property means that you can just flip around. If I have x equals 2, it's the same thing as writing 2 equals x. When there's an equal sign, it doesn't matter what's on the left and right hand side. You can switch the left with the right. That's called a symmetric property. It's used more in geometry. And deductive reasoning is the process of reasoning logically from given facts to a conclusion. So when we're going to solve equations, we're actually going to use deductive reasoning, go line by line, and show why we can do each step when we're solving an equation. So here are examples. We're just going to write the property that this is for each one. So 1 times m equals m. This is the multiplicative identity. You're multiplying something by 1 to get the original 1. Letter B, it's addition for sure, but we're changing the grouping symbol, so we're changing the association. So this is the associative property of addition. So So you should always write whether it's in multiplication or addition situation, and then write the property. This one we're changing the order is staying the same, but we're changing the grouping. So this is associative multiplication. And then this one we're adding 0 and we're getting the original number. So this is going to be the additive identity. And then this one we're changing the order and we're multiplying. So this is going to be the commutative property of multiplication. In this one we're adding, but we're changing the order. So that is the commutative property of addition. And the last part of this section is about matrices. It's just an introduction to matrices. So matrices are groups of information or numbers together, and they're used in business, and we actually use them for different applications in Algebra 2 and Geometry. But here in Algebra 1 we're just going to talk about the basics of adding them. So when you add two matrices, they have to be what's called the same dimensions. So dimensions are rows, the number of rows, by the number of columns. So to add two matrices, you need to have the same number of rows and columns. So if you look at this one has 2 rows and this one has 2 rows. This has 2 columns and this matrix has 2 columns. So we can add them. Same thing with B. And look at A. This has 3 rows, 1 column, and this has 3 rows, 1 column. So we can add them. So when we add or subtract matrices, we add or subtract their corresponding what's called elements. So the numbers within a matrix are called elements. So this is an element. This is an element. So to figure out the corresponding elements, I look at this 4 is in the upper left hand corner. So over here, this one is in the upper left hand corner. So I'm going to add these two together. So my matrix is going to be the same size, and I'm going to add up 4 and -1 and put it in this upper left hand corner. So that's 3. And then I'm going to add up -1 and 2 and put that in the upper right hand corner. So that's 1. I'm going to add up the lower right, or lower left, lower left. So -2 plus 2, those are additive inverses, I get 0. 5 plus -3, I get 2. So that's my answer for my matrix. So these two, I'm going to subtract. Subtracting is the same thing, so you do 6.1 minus 7. There's a subtraction sign in between. So 6.1 take away 7 is -9/10. And you can keep going. So you're looking at adding up the corresponding positions here.